Hello guys, I hope everyone is fine. So welcome to another session on coding practice on arrays. Today we are going to look at a very famous problem. Let's quickly jump to the problem. The problem is, given an array, find the sum of all possible subarrays. So I am given an array and I am going to find what is the sum of all possible subarrays of this array. Now remember, we are talking about subarrays, and there are a couple of assumptions that we are going to take. First of all, I'm not going to deal with a very large list of elements. The size, which we would refer to as n, would at most be 100, and the array elements itself would not go beyond the value of 100 or 1000 at the max. And we are going to talk about subarrays. We're going to talk about subarrays which are contiguous elements, and we are going to eliminate the empty subarray. The reason for eliminating the empty subarray is because it's not going to contribute to the total, so we are going to eliminate it. These are our possible subarrays of length 1, of length 2, length 3, and length 4. Okay, we have looked at an approach to solve this problem earlier. This is in fact the second discussion on it, but I'm just going to quickly uh, take you through it. The brute force approach was what was used in the previous session. What we did was we generated all possible subarrays and then we tried to compute its sum. The process of generating all subarrays, since it's a brute force approach, involved nesting of loops. I went ahead and we saw that 3 loops were nested. We wrote a code for it, and that raised the time complexity to big O of n cube. That meant with an array of size 10, you would end up with 1000 iterations. So you can well imagine what happens if you had an array of size 100. Okay, so the question is, can you come up with a better approach? Of course, any problem can be solved in a number of ways, and we can definitely have a better approach to solve this particular problem as well. So let's discuss this approach. I will quickly jump to the place where we are going to code our solution. Before we code our solution, let's have a discussion on what is the right way, or what is the more efficient way of solving this problem. See, this is what we saw earlier in a session, that I was using 3 nested loops, thereby resulting in a computationally expensive code. The time complexity of the same was big O of n cube. I'm going to use another file. I'm going to call it sum of subarrays E. E stands for enhanced.cpp, or efficient, you could say. Okay, let's look at the array in question. So this is the array in question. Okay, so what I'm going to do is, let's go ahead and list out all subarrays which has 1 as the first element, or as the starting element. This would be 1, subarray of length 1, subarray of length 2, subarray of length 3, and subarray of length 4. Okay, let me list out all the subarrays which has 2 as its starting position, which will be 2, 2, 3, and 2, 3, 4. Let's list out all elements which has 3 as its starting position, which would be 3 and 3, 4. And let's list out all the subarrays which has 4 as its starting position. So if you go ahead and count how many times did 1 occur, so you'll find out 1, 2, 3, 4. So 1 occurs 4 times. Let's find out how many times does 2 occur. 1, 2, 3, 4, 5, 6. So 2 occurs a total of 6 times. Let's see how many times does 3 occur. 3 would occur 1, 2, 3, 4, 5, 6 times. And if you look at 4, you will find that 4 occurs 1, 2, 3, 4 times. Let's split it down further. Let's see how many subarrays do we have with 1 at its starting position. So if you look at it, you will find that the number of subarrays which has 1 at their starting position are 4. Let's find out how many subarrays does 2 have as its starting position. So total number of subarrays are 3 with 3 at its starting position. These are 2 with 4 at its starting position. So I'm left with only 1. So this gives us a nice formula if you want to determine how many elements or what is the number of subarrays which has a particular element at its starting position. So I can say n minus I, where n happens to be the size of the array and I happens to be the index, right? So for this particular case, you could say that n for the entire array, the size is 4, why it has 4 elements, and here I would be addressing I as 0, I as 1, I as 2, and I as 3. I is the index. So index 0, index 1, index 2, and index 3. Okay, let's go a little bit further. How many occurrences are we left with? The total number of occurrences are 4. So how many occurrences am I left with? 1. If I subtract this 4 from this, the answer is 0. I'm left with 0 occurrences. Let's see what happens to the total number of times the 2 occurs is 6 times. So if you go ahead and if you subtract this 3, I will be left with 3 occurrences. Let's talk about 3. So 3 occurs a total of 6 times. So if you subtract 2 from it, you will be left with 4. Let's talk about 4. 4 occurs a total of 4 times. You subtract 1 from it, you would be left with 3. Okay, so let's try to formulate a formula. So if you go ahead and if you try out this formula, so this would give me the total number of occurrences. Remember, I happens to be my index, n happens to be my total number of elements. So I'll just list out the indices. Okay, so let's see what happens. N minus I, 4 minus 0 multiplied by 0. 0, it works well for it. Let's see if it works well for 2. 4 minus 1, which is 3, multiplied by 1, 3. So for 2, I get the answer as 3, which seems fine. Let's talk about 3. If we are using 3, then what would happen is I would end up n, which is nothing but 4. 4 minus 2, which is 2, multiplied by 2, which is 4. So satisfies this. And let's talk about 4. If I take 4, I would end up with n, which is 4, minus I, which is 3, multiplied by I, which is 3. 4 minus 3 gives me 1. 1 multiplied by 3 is 3. So this formula seems to be okay. So if I combine both of them like this, n minus I, and I do an n minus I, so I would end up with the total number of occurrences. This formula can now be shortened into this, right? So I would be ending up with the total number of occurrences of a particular array element. Now I wanted to find out these number of occurrences. Why? Because if you go ahead and if you multiply 1 by 4, add 2 multiplied by 6, add 3 multiplied by 6, add 4 multiplied by 4, you are going to get an answer. Let's see, 1 into 4 gives us 4, 2 into 6 gives us 12, 6 or 3 into 6 gives us 18, 4 into 4 gives us 16. So 4 plus 12, 16 plus 18, 34 plus 16, 50, which gives us the sum of all subarrays of this particular array. So when we come up with this simplified formula, I would be able to find this thing here, this thing, total number of occurrences of a particular array element. Since I will be able to find the total number of occurrences of a particular array element, I should be able to get the sum. Let me comment all this and let's start by writing my IOStream header file using standard namespace. I'm going to go into the main function. Let's stick to this array itself. 1 2 3 4. Let's find out the size. Remember, we can calculate the size using size of a divided by size of a0. So n would come out to be 4. If I print n at this junction, at this instant, it's going to print as 4. I would also need a variable total. I would need to set it to 0. The reason I'm setting it to 0 is because it is responsible for holding the sum of all subarrays of this array. Let me run a loop. I is 0, I is less than 4, not 4. Let me use a dynamic piece. I is less than n. So total plus equal, that means add to the previous total, a of I, remember a of I is the element, multiplied by n minus I multiplied by I plus 1. See out total end line. Now before we go any further, let's compile and let's run this code, and let's make sure that we are getting the right answer. G++ sum of subarrays efficient CPP. Okay, lucky there, no errors. Let me, so 50 is the answer. 50 is the answer that we expected, so it seems fine. Let's analyze the code line by line. See, the code has shortened. I only have 5 lines if I don't count the curly brackets and the int main function. You have an array, you have it filled with elements 1 2 3 4. You have the total variable, which is supposed to hold the sum of all elements. You get n, which is nothing but is a variable which is going to hold the size of the array. So what do? Size of a divided by size of a0, and then you run a loop. Simply run a loop from here. What does it do? Total, you need to add to its old value ai. Remember, it gives me this element. Why? Because I need to target this formula ai. When I is 0, 0 is less than 4, of course, so I would end up writing a of 0, which is 1, multiplied by n minus I. N minus I is nothing but 4 minus 0, 4 minus 0 multiplied by I plus 1, which is nothing but 0 plus 1. So if I do this, I would end up adding 4. Now if you look carefully, this is the exact 4 that I had gotten from this total number of occurrences of 1. Let's talk about 2. From 2 I am supposed to get 12. So let's see what happens. So if you go into 2, a of 1 will be 2 multiplied by n minus I, n, which is nothing but 4, 4 minus 1, because I is 1 now, multiplied by I plus 1, which is nothing but 1 plus 1 should give you 2. So this is what? 2 into 3 into 2. 2 into 3 is 6, into 2 is 12. So I'm going to get 12 out of it. According to this formula, 2 into 6 should give me 12. The same thing happens with 3, the same thing happens with 4, and ultimately I end up with 50 in the total, which I am printing on the screen. Okay, let's see. Let's say that my array was not 1 2 3 4. Let's shorten it, 1 2 3. So what is my answer? Does my code work for it? See, 20. What will be the possible subarrays, non-empty subarrays for 1 2 3? They would be 1 1 2 1 2 3 2 2 3, and finally 3. So 1 plus 1 2 plus 2 4 5 7 10 2 12 12 plus 5 17 plus 3 20. So 20 is the right answer. So I hope you guys enjoyed this video. This code snippet is available on the GitHub. Do let me know if you need this code snippet. I'll share it on the GitHub profile. And take care, guys. look forward to another video on arrays or other placement aspects. Thank you for attending this session. Take care.